This is the video for the types of chemical reactions lecture. This one is going to be really quick. We are just going to talk about the 5 types of chemical reactions that we will be seeing in this class. No predictions today. That will come here in the next few days. Today we are just going to talk about how to recognize a chemical reaction. The first chemical reaction we are going to look at is called a synthesis reaction. You can kind of see these pictures on the right, and that will help lead you to the kinds of reactions we're talking about. You can kind of tell from that picture, we're going to be taking reactant A, reactant B, and combining them into a single compound AB. So A and B tend to be 2 reactants that are elements. And they combine to make a single product. So a generic equation there, A plus B makes AB. You can also kind of think about this as element plus element makes a compound. You're going to notice as we go through this lecture that the distinguishing feature we're going to talk about every single time has to deal with the reactants. So here you could recognize that it's a synthesis reaction because you start with 2 elements. Reaction number 2 is called a decomposition reaction, or a decomp. Its generic equation is if I have compound AB that will split to create elements A and elements B as products. So kind of a little bit more generic, compound becomes element plus element. The distinguishing feature here is very easy. You only have a single reactant. It will always be a single compound. If you have just a single reactant, you know that it's going to be a decomposition reaction, and that reactant will decompose into its elemental pieces. Reaction number 3 is called a single replacement reaction. Here, you have an element, A, and a compound, BC. The reaction takes place, and A is going to switch with one of those 2 parts of the reaction. So you might get compound AC and free up element B. So you can see there that the C portion of that compound jump shift and create a new compound. In general, if you want to think about this in terms of elements and compounds, I have an element plus a compound yields an element plus a compound. Distinguishing feature here when you look at your reactants, you will have 1 element and 1 compound to start. So you can see you'll start with 1 element and 1 compound. That's how you recognize a single replacement reaction. Reaction type number 4 is called a double replacement reaction. In a double replacement reaction, you are going to start with 2 compounds. So maybe you have A, B, and C, D. And what's going to happen is the first part of each reactant is going to flip. So the A will go switch with C to create new compounds AD and CB. Again, if you want to think about this in terms of elements and compounds, you will start with compounds. You will end with 2 new compounds. Distinguishing feature, you have 2 compounds as reactants. So these 4 are very kind of general as far as their distinguishing features. A synthesis has 2 reactants that are elements. For a decomposition, you just have a single reactant, which will always be a compound. In a single replacement, you have one element and one compound as your starting points, your reactants. And in a double replacement, you will have two compounds as your reactants. The fifth kind of reaction is our combustion reaction. And it is a little bit more specific. It tends to have a little bit more pattern to it. It will always be a hydrocarbon. So remember a hydrocarbon from last year, something that's made of C's and H's. The X and the Y there are just the subscripts. You can have multiple C's, multiple H's, but the number of them doesn't really matter. It's always going to be some combination of C's and H, plus oxygen, which will always be O2, will always make the same two products. It will always make H2O and carbon dioxide. So even though that this is a generic equation, combustions always kind of take the same pattern. You have a hydrocarbon, so this X and this Y is the only thing that ever really changes, the number of carbons and hydrogens, plus oxygen makes water and carbon dioxide. So distinguishing feature, how do you recognize it? Your reactants are always going to be a hydrocarbon plus oxygen. I'll even write that out since we're using words, plus oxygen. If these are your reactants, you know you have a combustion every single time. So let's do a few practice problems now that we have seen our various reaction types. I can look at this first reaction here. I can see that I have an element and a compound as my starting reactants. That's going to tell me this is a single replacement reaction. The magnesium is going to attack that compound and try to take the place of something in that compound. We can see on the product side that it does in fact succeed. The magnesium goes in and takes the place of the hydrogen. And so now we just have to balance it, which we learned how to do yesterday. So let's look. I have one PO4 on the left, two PO4s on the right, so that's going to tell me that's a 2. That gives me 6 hydrogens on the left, which gives me 3 hydrogens, 3 H2s, so 6 hydrogens on the right. Last but not least is my Mg. I have 1 on the left, 3 on the right, so that's going to give me a 3 there. And as long as we're in Unit 10, you are allowed to go ahead and put a 1 there, but remember those 1s need to eventually go away. So the balancing there was all stuff we did yesterday. The only new thing there was identifying it as a single replacement reaction. Moving on to number 2, we can look and see that I have a hydrocarbon plus oxygen. And as soon as I have that hydrocarbon plus oxygen, that tells me it's a combustion reaction. For balancing, we practiced this yesterday. 4 C's gives me 4 C's there. 10 H's tells me that's going to be a 5 there. And remember, O's for combustions can be a little tricky. I have 8 O's from CO2. I have 5 O's from H2O, which gives me a grand total of 13 O's on the right side. I can start by putting a 6.5 next to O2, but I can't leave that as a decimal, so I have to go through and multiply every one of those by 2. That becomes 13, that guy becomes 8, and that guy becomes 10. Again, the only new thing here was that identifying the new reaction. Looking at number 3, I have Li2O, and that is my only reactant. It's because they only have one reactant. This must be a decomposition reaction. And balancing, these guys are generally pretty quick. We can do O's first. I have 1 O on the left, 2 O's on the right. So I'm going to put a 2 there, which gives me 4 LIs. For number 4, I have a compound and a compound as my reactants, K2CrO4 and AlCl3. Anytime I have 2 compounds as reactants, that will always be a double replacement reaction. The K will switch with the Al to make two new products, KCl and Al2CrO4 So to balance, you figure out where you want to start. Let's look at Ks. I have two Ks on the left, one on the right, so that gives me a 2 there. Now maybe you want to look at Cl, and you kind of see I have 2 on the right, 3 on the left, which means I'm actually going to not need a 2 there. That's going to end up being a 6. And I'm going to need 2 AlCl3s. Well, now that I've changed that to a 6, I'm going to have to go back to my Ks, give me 3 there, 2 Als, 2 Als, 3 CrO4, 3 CrO4, and we are good to go. Number 5, I have hydrogen plus phosphorus. This time I didn't give you the symbols. You can still recognize the type of reaction, though, because you know that both hydrogen and phosphorus are elements. So I have an element plus an element. That is always going to be a synthesis reaction. But if we're also going to balance it, we do have to write the symbols first. Hydrogen is H2, it's a diatomic. Phosphorus is just P, and hydrophosphoric acid is going to be H3P. We know that P has a -3 charge, H is a +1, so it gets me H3P. Now I can balance this out nice and easy. I'm going to need 3 H2s for my 2 H3P, and then 2 P's to finish that off. Last but not least, number 6, I have an element plus a compound. That tells me this is going to be a single replacement reaction. Iron is Fe. Gold, 3 sulfate. I know gold is Au with a +3 charge because I have a Roman numeral 3. Sulfate you can look up on the chart, SO4 -2. Gives me my formula, Au2SO4 3. On the other side, I got gold, which is just Au, and I have iron 2 sulfate. Iron is still Fe, but this time it's +2. Sulfate is SO4 -2, which gives me my formula FeSO4. Balancing that out, I have 3 SO4s on the right, on the left, 1 SO4 on the right, so I'm going to need a 3 there, which gives me 3 Fes. I have 2 Aus on the left, so I'm going to have a 2 right there, and we're all good and balanced. This last page is just your practice. We're not going to do any here, but identifying should always be your primary focus. For right now, we have given you the entire equation, reactants and products. But remember, starting tomorrow with our next unit or with our next lesson, this half is going to go away, and it will be on you to predict what you make. The only way to do that is to be able to identify your reactions correctly. And you can only do that if you recognize the reactants. So looking at that example right there, you could say, oh, I know I have two elements. That's going to be a synthesis. And then after tomorrow, you'll know how to predict the product of a synthesis. Please practice and let us know if you have any questions.